Have you ever stared at something truly mind-boggling, like um, a Mars rover sending back pictures,
Wow.
or maybe a surgeon guiding a robot through some super delicate procedure,
Uh-huh.
or even just the incredibly sleek device you might be listening to this on right now,
Right.
and found yourself wondering, how did that even begin? What
Mm.
intricate dance of elements and effort went into making that, like, audacious idea a tangible reality?
It's a great question.
Well, today we're taking a deep dive into something called the 7 resources of technology.
Mm.
It's basically a framework that helps us uncover the fundamental building blocks, the driving forces behind, well, every single technological marvel we encounter.
Pretty much everything.
Yeah, our mission is to go beyond the surface and explore the often hidden components that support technology's creation, its operation, and its constant evolution.
It's a fantastic lens to view the world through, really. Because what's truly fascinating, I think, is realizing that no invention, no matter how simple or revolutionary, it doesn't just spring fully formed from, one single spark of genius.
Right, it's not magic.
Not at all. Instead, it's always this sophisticated orchestration of many different ingredients, or like we're calling them resources,
Mm-hmm.
all working together.
Mm-hmm.
So let's imagine for a sec, if we were like visionary architects designing something truly transformative, maybe a sustainable floating city,
Cool.
which of these unseen resources do you think would be the most difficult to get or manage effectively?
Hmm.
It's rarely the obvious answer, is it?
That's a great challenge to kick us off, and it really drives home the core idea. A resource, in this context, is anything, absolutely anything, that provides essential support for technology.
Right, of course.
Whether that's bringing it to life, keeping it running, or, making it better.
Exactly.
And here's where it gets really interesting for me. It's not just about having one key component.
No.
Think of it like baking a really elaborate cake. You wouldn't just throw in flour and expect a masterpiece.
Right. Definitely not. Needs more stuff.
You need eggs, sugar, butter, maybe some exotic spices for that extra zing.
Yeah.
And they all have to be combined in just the right way.
Uh-huh.
Every single piece of technology, from like a simple lever to the Large Hadron Collider, relies on a unique combination of these essential resources.
A mix. Always a mix.
Okay, let's start with maybe the most obvious, yet sometimes underappreciated element, people.
Ah, yes.
We're talking about the absolute bedrock of all innovation. It's human ingenuity, that spark of curiosity, the relentless drive to solve problems that truly initiates and guides technology. People bring just a vast array of knowledge, specialized skills, incredible creativity, and often sheer stubbornness, right,
Yeah.
to the table.
And it's such a spectrum of human involvement, isn't it?
Totally.
From the theoretical physicist sketching out some revolutionary concept on a whiteboard,
Yeah.
to the software engineer who's meticulously coding algorithms, to the skilled technician on the factory floor, calibrating machinery.
Right.
Without their diverse expertise, the most advanced tools are literally just inert. They don't do anything.
Just lumps of metal and plastic.
Exactly. And what's particularly compelling today is how we're seeing new specialties emerge, like ethical AI designers or quantum computing architects.
Whoa.
Roles that kind of blur the lines between traditional disciplines, needing not just deep technical knowledge, but also critical thinking about societal impact. It's this constant evolution of human skill sets adapting to and shaping new technologies.
Yeah, it's true. It's not just about one brilliant inventor in a garage anymore, is it? It's a whole symphony of minds.
Absolutely.
Okay, but let's move from the minds to what those minds generate and consume. Information.
Ooh, important one. Often invisible.
Totally invisible, but absolutely vital. Technology fundamentally relies on accurate data, precise instructions, and clear, well-structured knowledge. You can't build a skyscraper without incredibly detailed blueprints, right? Or try navigating an unfamiliar city without a reliable map app on your phone. It just wouldn't work.
Precisely. And in our increasingly data-driven world, the quality of that information is just paramount.
Quality, yeah.
We've moved way beyond simple blueprints now. We're talking a complex data models, simulations, real-time streams of telemetry.
Wow.
Think about autonomous vehicles, self-driving cars. They rely on petabytes, like massive amounts of sensor data, mapping info, predictive algorithms. Now, a single piece of incorrect or incomplete data, like a mislabeled stop sign in a training data set, for example,
Oh, boy.
that can have catastrophic consequences. It really raises an important question for tech developers. How do you ensure the veracity, the integrity, the truth of this vast ocean of information your systems depend on?
Yeah, how do you trust it?
It's not just about having data, it's about having trustworthy data. And that's a constant battle against noise, bias, even, malicious intent.
Absolutely.
Yeah.
Okay, so next resource is something we can actually hold, something foundational. Materials.
The physical stuff, the building blocks.
The literal building blocks that give technology its form and function. When you think about materials, your mind might jump to, like, natural resources like wood or iron.
Sure.
Or maybe synthetic ones like plastic. But what's truly fascinating now is how advanced tech is pushing the boundaries of material science itself.
Indeed. We're talking about everything from the mundane, like sand.
Sand.
Yeah, to make silicon chips, the bedrock of computing. But it takes immense energy and complex processes to refine it.
Oh, okay.
Then there are critical minerals like lithium, cobalt, rare earth elements essential for batteries, high-tech electronics. The global competition for these is intense.
I bet.
It leads to complex geopolitics, and it's driving innovation in recycling and material substitution. We're also seeing the rise of smart materials, stuff that can change properties on command, or biomaterials that interact seamlessly with living tissue. The future of tech is going to be heavily influenced by our ability to discover, process, and sustainably manage these increasingly complex materials. It forces us to ask, how do we decouple tech progress from environmental impact through smarter material choices?
That's a huge challenge and, yeah, a reminder of how interconnected everything is.
Yeah.
Okay, next up, the force that makes everything move, glow, hum, compute. Energy.
Gotta have the juice.
Exactly. This resource drives every single stage of technology, from extracting and refining those materials we just talked about, to powering the factories that assemble components, and ultimately to operating the final product in our hands.
Energy is the lifeblood. Historically, technology advanced hand in hand with our ability to harness more powerful energy, right? Steam engine, internal combustion engine, then electricity.
Right.
Today, the conversation is dominated by efficiency and sustainability. We're still heavily reliant on fossil fuels, sure, but the push towards renewables like solar, wind, geothermal is accelerating.
Yeah, you see solar panels everywhere now.
Exactly. And this shift isn't just about being green. It's about energy security, creating more resilient tech infrastructures. But even renewables have challenges: intermittency, storage, grid integration.
Right, the sun doesn't always shine.
Precisely. And think about the energy demands of emerging tech, like AI models training on massive data sets. They consume enormous amounts of electricity.
Huh. Didn't think about that.
The choices we make about energy will fundamentally shape what future technologies are even feasible and how they operate within, planetary boundaries. It really makes you think about the hidden energy footprint of your everyday devices, doesn't it?
It certainly does. Okay, now let's talk about the aids that extend our reach and multiply our capabilities. Tools and machines.
The enablers.
These are the literal instruments that help us actually build and operate all other technologies. They're the devices that amplify human strength, precision, speed, allowing us to do stuff impossible with just our bare hands.
Exactly. From the earliest hammer to the most sophisticated quantum computer, tools have always been central to human progress. What's compelling about modern tools and machines is their increasing autonomy and precision. Think about additive manufacturing, 3D printing.
Oh yeah, 3D printers are cool.
They can create incredibly complex shapes, layer by layer, revolutionizing prototyping, custom production, or robotic surgery, where machines enhance a surgeon's dexterity beyond human limits.
Wow.
The integration of AI into industrial machines is transforming entire factories into smart environments with predictive maintenance, optimized schedules.
So the machines are getting smarter.
Smarter, faster, more precise. The question here isn't just what machines can do, but how they're changing the relationship between human labor and automation. They aren't just doing tasks faster, they're enabling entirely new kinds of tasks and capabilities. It forces us to reconsider the definition of skill in an age where machines can do so much so accurately.
That's a profound point. And speaking of enabling, our next resource often feels like the ultimate enabler. Money.
Ah, yes, can't do much without it.
This is the financial fuel that ignites and sustains every single stage of technology development. Without it, even the most groundbreaking idea often remains just that, an idea. Maybe a brilliant sketch on a napkin.
Money is the engine of innovation, plain and simple. It funds the initial research, the design, the prototyping, the rigorous testing, the complex manufacturing, even the distribution and marketing to get the tech into people's hands.
Right. Every step costs something.
Think about the massive investments needed for developing a new generation of microprocessors or launching a satellite constellation. Not cheap.
No kidding.
The sources are diverse too. Government grants, venture capital, corporate R&D, even crowdfunding for smaller projects. What's often overlooked is patient capital investment willing to wait years, decades sometimes, for a return. That's crucial for really disruptive long-term breakthroughs like fusion energy or advanced numerical research.
Oh, okay. Long game.
Exactly. So while human need often sparks the initial creative impulse, money is the relentless force that allows that impulse to be nurtured, grown, and ultimately realized. It's a complex dance between brilliant ideas looking for cash and cash looking for brilliant ideas.
Makes sense. And finally, a resource we all constantly battle for, and one that impacts every other resource we've discussed. Time.
The big one. Always running out.
It's the non-renewable currency that shapes every part of technology's journey. From the initial idea and meticulous design, through rigorous testing and actual production, to, how quickly people actually start using it.
Time is indeed the ultimate trade-off in technology, rushing development. That can lead to unforeseen bugs, safety issues, bad reputation. Remember early software glitches or product recalls?
Oh yeah, big mistakes.
But conversely, taking too long can mean missing the market opportunity entirely. Your competitors innovate faster.
Right, you snooze, you lose.
We saw this dramatically during the COVID-19 pandemic. Vaccine development timelines were compressed from years down to months. Incredible mobilization.
That was amazing.
But that accelerated timeline was only possible because of decades of prior research, massive global coordination, and huge financial investment. It highlighted that time can be managed, compressed, or expanded, but it always has a cost. The challenge for innovators is optimizing that timeline, balancing speed to market with quality, reliability, thoroughness. It makes you consider not just how long something takes to build, but how long it should take to ensure it's truly ready.
Okay, so wow. We've broken down these 7 distinct resources: people, information materials, energy, tools and machines, money and time.
Yep, the big 7.
But how do they actually intertwine and work together in the real world? Let's take something almost everyone has nearby, your smartphone.
Perfect example, a pocket marvel.
It really is. Imagine we're taking it apart, like piece by piece, to truly see these resources in action.
Fantastic idea. Let's really peel back the layers.
Okay, so first, people. Who designed that incredibly thin, vibrant display?
Right, the screen engineers.
Who engineered the tiny, powerful processor inside? Who wrote the billions of lines of code that make the operating system run so smoothly?
Software developers, testers.
We're talking thousands, maybe hundreds of thousands, of specialized individuals across multiple continents: industrial designers, electrical engineers, software developers, material scientists.
Factory workers assembling it.
Even the marketing teams who shape how we perceive and desire the device. Each one is a critical human cog.
Absolutely. And that leads directly to information. Every single aspect of that phone, from its internal circuit board layout to the intuitive user interface, it's all the result of vast amounts of information. Design specs, engineering blueprints, patented algorithms, complex software code,
Manufacturing process data.
quality control reports, even the app store you browse. Pure information guiding your choices. The phone itself is a highly sophisticated information processing machine, totally reliant on the integrity and speed of data.
Okay, then the tangible stuff. Materials. Look at it. What makes up that sleek body?
Glass, metal, maybe some plastic.
Yeah, but inside, you've got rare earth elements for its vibrant colors, lithium and cobalt in its battery,
Gold and platinum in its tiny connectors.
silicon for its processing chip. These materials are sourced from mines across the globe, refined in complex facilities, then precision engineered into components. It's like a global scavenger hunt for these critical bits.
It really is. And all those materials, all that design requires immense energy.
Oh, yeah.
From the powerful electric furnaces melting metals to the clean rooms where microchips are fabricated using intense lasers to the high-speed robotic assembly lines and massive factories. And of course, the energy stored in its battery and the electricity from your charger that powers its daily use. The whole life cycle of that phone is an energy-intensive journey.
Which brings us to tools and machines.
Hmm.
You can't just hand assemble these tiny, intricate components,
Right
right?
away. Need robots.
Precision robotics are essential for placing microscopic chips. Advanced fabrication tools, some costing millions of dollars, create the processor. Optical inspection systems ensure quality.
And even the software development itself relies on powerful computers, sophisticated programming environments. Every stage demands cutting-edge machinery.
Okay, and none of this,
Yeah.
absolutely none, happens without massive money.
Billions with a B.
Billions poured into R&D for new screens, faster chips, better batteries. Factories cost hundreds of millions to build and equip.
Supply chains need funding.
Global marketing campaigns require huge investment. The entire ecosystem of a modern smartphone, from concept to your pocket, represents an enormous financial commitment, often spanning decades of cumulative investment.
It's staggering, really.
And finally, time. How many years did it take to get from the very first clunky mobile phone concept to the smartphone in your hand today?
Decades. Decades of cumulative research, tiny improvements, and then accelerated development cycles.
Each new generation of phone represents years of planning, design, testing, production. It's this relentless race against the clock to innovate faster than the competition.
While ensuring quality and reliability, that time pressure is immense.
See, your smartphone isn't simple at all. It's an incredibly complex symphony of all these resources orchestrated globally, often with breathtaking speed. When you start to consider it this way, it truly is mind-blowing, isn't it?
Absolutely. And once you begin to identify these 7 resources, you really do start to see them everywhere.
Yeah.
Whether it's a simple everyday object like, I don't know, a fountain pen, or something as grand as the International Space Station.
Wow, yeah. Big difference in scale.
Huge difference. But they all require a careful, deliberate combination of these elements to exist and function. People, information, materials, energy, tools and machines, money, time. They're kind of the universal language of technological creation.
So the next time you marvel at a new app or encounter some unexpected technological innovation, I want you to challenge yourself. Which of these 7 resources do you think presented the greatest hurdle for its creation?
Interesting question.
Was it like the scarcity of a particular material, the time crunch for development, or maybe the sheer number of skilled people needed?
It could be anyone or combination.
And then imagine how profoundly different our world would be if even one of those critical resources suddenly became unavailable for that specific technology. What would happen? The implications are often far deeper than we initially realize.
Really makes you think.
Keep exploring, keep questioning, and keep making those incredible connections in the amazing technological world that surrounds you every single day. Have you ever stared at